let's stick with the same setup here with this circle. Now, what if I really don't care about, oops, that's not good. What if I really don't care about the y-coordinate? What if I really just don't care? Okay, that is, and I really am much more interested in knowing the distribution, or there's something about the behavior of the x-coordinate. That is, you think of it as turning this guy on its side, right? Where does x tend to be? Hey, look at this. Look at this. It's not actually uniform. The behavior of x is not uniform between these two marks, is it? Now, the point itself, where your dart lands is going to be, it's uniformly distributed in here, right? Right? But if I make a bunch of dots, sort of, uniformly around inside this circle, but now if I turn it up on its end like this, you're not going to see this very well, but you're going to tend to see more clustering here in the middle, because there's more middle, right? If you turn it up this way, there's more in the middle, right? Because these edges are, it's not square. These are hacked off, right? You don't have any dots up here, but you've got a larger swath of the circle there in the middle, right? So in fact, the density function for x should kind of, it should sort of go up like that, I think, something like that. Okay, so that's what we're interested in. What does the density function for x look like? Well, I'm glad you asked. Here's how we can get this. The density function for x, also called the marginal now, we'll call it the marginal density function for x, simply because we know that there's this other random variable out there, but it's, the marginal density function just is the density function. Okay, I'm going to integrate over all the reals the joint density function for the two variables, but just with respect to y. I'm going to integrate out the y, so to speak. Now, I know that joint density function now is 1 over pi r squared times the indicator that x squared plus y squared is less or equal to r, right? Like that, and then dy, right? Okay. So what I can do is I can go ahead and pull out that 1 over pi r squared, and let's see. Now, y is going to go from where to where? It certainly kind of goes from negative r to r, but no, remember that this is a function of x, okay? This is a function of x. So pick an x somewhere and fix it. Where does y go? It's the same kind of deal as before, from negative root r squared minus x to positive root r squared minus x, okay? So negative root r squared minus x to positive root r squared minus x. All right, and so yeah, so this indicator function then is just 1 dy. I do need to stipulate though that my absolute value of x is less or equal to r. Okay, so that I can keep this because I want this marginal density function to be defined over the entire real line. Okay, all right. So then, what is that? Oh well, that's just 1 over pi r squared. This becomes y evaluated there. Take to these limits, I think it's just it's 2 times root r squared minus x squared, and then times that indicator function, right? That x is between negative r and r. Same thing as that. Okay, so this is my my density function there. My marginal density function for x, and in fact, by symmetry, you should see that the marginal density function for the y variable is exactly the same thing. Okay, just 2 over pi r squared, and then times root r squared minus y squared times the indicator of y being between negative r and r, like this. Okay. And you know what? Let's graph that density function. Might be kind of neat. it should, again, and I don't know exactly what it looks like, but it should kind of go up, and it should be higher in the middle, and then also be symmetrical like this, unimodal and symmetric like this. So I'm just going to put that in there. It's 2 divided by pi Beavis, 2 divided by pi r squared. I don't know. I'll use r equals 1. Okay, and then multiply the whole thing by the square root of 1 squared minus y squared, x squared, whatever. Let's see, 1 squared minus x squared. Okay. All right. Well, I'm having a hard time with this. This is, I'm just going to have to start that stuff over. Shoot. I hate this calculator. It sucks. 2 divided by pi times r is 1. Okay? Because I said it is. That's why. Minus x squared. Good. Now, let's graph that guy. And I gotta set my window right. Set my window to be like, negative 2 up to 2. And then from 0 to, I don't know, 2. Let's take a look. I didn't like that. Negative 2 to 2. Okay. Okay. Yeah, okay. So it does sort of look like that. It goes up and then it comes down. It's unimodal there and there. Good. I was right, as usual.